What's up, Algebra 1 students? This is lesson 30. Our objective is, how do you graph functions? And, well, the short answer to that, I guess, is to plot a bunch of points and then see what it looks like. But just as a way to kind of be a helpful hint, here are 5 parent functions. And parent function is just kind of like a basic function that says, if they're in this family, they're going to look something like this. The first one is just the line y equals x. That's a family of all linear equations. And we've worked with those before. Sometimes they're moved up or down, or they slope downwards, or vertical or horizontal or something like that. And that's just the parent functions that are linear, and so they're all going to be just a straight line. Next one is y equals x squared. This is a parabola shape. And again, sometimes it's narrower or wider, moved up and down, or flipped upside down or something. But they're going to have this same basic kind of U-shaped, if you want to say, a parabola shape, evolved in there in that x squared family. X cubed family, we have negatives and positives. It kind of goes in this shape. Again, steeper or less steep, something like that. Absolute value function looks pretty similar over here to this part, to the y equals x, but over here where they're negative, it's flipped up to make it positive. So this is the function y equals the absolute value of x. And the square root function starts at 0, 0 and kind of goes off to the right. Up and swooping off to the right. So that's kind of just some basic ideas. So if you see something that has like an x squared in it, or the absolute value of x, or just y equals x, or square root of x, or x cubed, that it's going to have a basic idea of what it's going to look like based on its parent function. So let's go ahead and just try some of these. It just says graph each equation using a table of values. So what we're going to do is we're just going to make up some values that we want to use. Maybe like -2, -1, 0, 1, 2, and I don't know, 3, just for fun. So what we're going to do is we're going to start plugging these values in to our equation and find the y values. Remember, we have independent variables and dependent variables. Independent variables are our x's, and we can pick whatever we want, ones that will make it easy, or something like that. So I just went through and picked some of these. So let's start plugging these in. So to find the y values, so we're going to say y is equal to 2 times -2 minus 5. 2 times -2 is -4, minus 5 is going to give me -9. So now I have a point -2, -9. Let's try the next one. Y is equal to 2 times -1 minus 5. That's going to be -2 minus 5, which is equal to -7. So it's going to be the y value there. And I don't know why I wrote -7. Let's try 0. Y is equal to 2 times 0 minus 5. That's just equal to 0 minus 5, which is equal to a -5. Maybe we can get this in here. Y is equal to 2 times 1 minus 5. It's equal to 2 minus 5, which is equal to -3. Y is equal to 2 times 2 minus 5. This is going to be 4 minus 5, which is -1. And then last one here, y is going to equal to 2 times 3 minus 5, which is going to give me 6 minus 5, which is equal to 1. So now I have a table of values. So now I just need to go through and plot these. The first one we have -2, -9 is actually off our chart, right? It's going to be down here. So I'm not going to be able to graph that one. Same thing with the second one here. negative 1, negative 7 is going to be right down in this area. So I'm not going to be able to graph that one. So I'm going to skip these two. I'm going to start right here at this 0, negative 5. So x is 0, y is negative 5. I'm going to put that point right there. When x is 1, y is negative 3. X is 2, y is negative 1. When x is 3, y is 1. And it looks like we're kind of keeping that pattern going up 2 over 1. So if we wanted to keep plotting following that same pattern, or if we wanted to plug in more points and find those, we'd end up with this. I just realized I can graph this one right here. That's right there at that point. Was at negative 1, negative 7. So we just didn't do that one because it didn't fit on here. Then we connect all our dots. Of course, there's infinitely many more dots we could have plugged into this and found. That's going to be the graph of that. And notice our parent function here is just a y and an x. Alright? So parent function is linear. Okay. Now looking at the parent function of this next one, notice we have y equals something with x squared in it. So we're going to get that kind of parabola shape there of some kind. So let's see if we can choose some points here. Let's go negative 2. Let's go the same ones. Negative 1, 0, 1, 2, and 3. So plugging this in, y is going to equal to 3 times negative 2 squared. It's going to be 3 times negative 2 times negative 2 gives me positive 4, which is just going to give me 12. So negative 2 corresponds to 12. Let's plug in negative 1. Y is equal to 3 times negative 1 squared. It's going to be 3 times negative 1 times negative 1, which is just 1. It's going to equal to 3. Next one's going to be y is equal to 3 times 0 squared. Well, that's going to be 3 times 0, which is going to give me 0. Next one's going to be y is equal to 3 times 1 squared. 1 squared is 1, so it's going to be 3 times 1, which is 3. Y is equal to 3 times 2 squared. 3 times 4, 12. The next one's going to be y is equal to 3 times 3 squared. 3 times 9, which is going to be 27. So graphing these points. The first one, negative 2, 12, is off my chart, so I'm not going to be able to do that one. Same thing with the last two. I'm not going to be able to graph those. So let's start with that negative 1, 3. It's going to be right there. And we have 0, 0. That's right there. And then 1, 3. It's right there. And we know that if we go to 2, we're like way up this way. And at negative 2, we're way up this way. So we're going to know we're going to pass through in this area, right? I can't go any wider than that. Because I know at negative 2, I'm up there at 12. Okay. And there's a rough sketch of y is equal to 3x squared. Alright, now this next one is just matching. So we have some pictures there on the right that we're trying to match up with the equations here